Yes?
Co?
Yes?
Jo. Tak, poslední přednáška dneska. Halo. Ještě chvilku pozornosti. Já vím, že jste...
Last presentation.
Vím, že jste už to... Jste opilí borštěma. Takže poslední přednáška dneska. Zdeněk, Snow Crash, API, Blueprint a Němec.
Tak jo, ještě teda díky Honzo, než začnu, dostala se mi informace, že bych měl mluvit anglicky, takže jestli jste všichni jako OK s tím, tak já to přepnu do angličtiny, protože v češtině by to bylo jako hrozný, jo, možná horší než v té angličtině, ale k tomu musím podotknout, že jsem se připravoval česky a říkal jsem si, slajdy budou teda česky, když to mluvím česky, a snažil jsem se fakt počeštit spoustu výrazů, což uvidíte za chvíli, tak se za to omlouvám, jo, teda. Alright, so I'll try to lead this presentation in English. Okay. So I'll try to connect to what David said before about the PEG.js and PEG grammar. And I'll be talking about the Snow Crash, which is a parser I wrote for a language I sort of invented, or I came up with a language. So, and I don't actually really want to talk about how do you came up with the language and how do you do the parsing of the language. I I would like to talk about the consequences. When you came with this crazy idea, by the way, don't do that. You know, don't come up with your own language if you don't really have to. If you do, what happened if you came up with your own language and you want to parse it, and you know the consequences you might not realize at the first hand when you think that this might be a good idea. So, just out of curiosity, is there anybody here who came up with his own language or her own language and tried to roll the part? All right, two, three, okay, four. Okay, so as I said, sorry, the presentation is in Czech because I was about to present in Czech. I want to talk about what happens when you came up with the language, about the structure of the parser I wrote for this language, but surprisingly about many other things that are, you know, something you didn't realize when you think, hey, if there is a language I want to parse it. So that's something I consider really important, and I didn't see it beforehand. And in the end, I might, you know, mention what didn't quite work out as I wanted. So first, the language itself. It's called API Blueprint. I believe some of you might know it, and just please don't blame me or hit me if you don't like it for some reason. But I want to, you know, if you happen to know it, I want to hear your opinion on it, of course. And so, what is API Blueprint? API Blueprint is a language for describing web APIs. It's more oriented towards the documentation. So, let's say you want to document a web API. And, as such, it started with a version, we call it Legacy or 1.0, and it was pretty much what you actually seen on David's presentation. Somewhat what you see when you do a CURL command on the terminal. It's basically, you know, the HTTP verb and URI and headers and some loading. And soon we realized that might not do quite well for where we want to take it, and we had to come up with something radically different, which is the, now we call it the new format or 1A. And so the first one was pretty much a plain text, basically a dump from a CURL. The second, the nowadays format, the new format, is a Markdown. So if you know Markdown, if you use Markdown on Stack Overflow or GitHub or I don't know where, you might get somewhat familiar with that, and also you get some benefits with you know, going Markdown. Okay, so why do we need this to describe APIs? That's what we do at API, which is a component that came up with the format, or I wrote for it, I forgot to say. And in API, the API Blueprint, the description of an API drives pretty much everything that happens in there. So, you know, let's say you want to build a web or HTTP API, and we think that it's a good idea to describe it first before you start, you know, writing a backend in Ruby or Python or whatever. So you describe it first, sort of like TDD or BDD, this approach where you first write the test and then you start implementing it. You first, do this construct, you describe your API with this format, and then we give you immediately a mock server to you, so you can start calling the API, even if it doesn't exist. You just describe the interface basically, and then you can implement it and you can use it, and we give you a documentation from that. And there is also testing that to make sure that what you read in the description is actually what the implementation is done. So that's really brief about the format. The first version, as I said, was really similar. If you look here, it's somewhat similar to what David showed in this example. HTTP verb, URI, some headers, some body. So that was pretty much the first format, where there was a little bit of Markdown stick here and there, where you could have some Markdown formatting for your documentation. So pretty much this was the documentation, and this was like something between programming language and what you see overall. The first format was surprisingly, or maybe not, written using Peg.js, David's product, David's parser, and he also helped us with writing the grammar. So what you've seen before was really, actually, when David asked who's like some high profile, using Peg.js, we're still eBay,
I knew
you guys know so alright. So, okay. Alright, so that was, it worked quite really well. And as a benefit, since it's written in JavaScript, it worked on the client side, so you could parse it in the browser. Which was pretty cool. There was somewhat, to some extent, a limited support for handling errors. Yet there is still some, but I wanted something more, so just doesn't owe me explode here, something missing. I'll get to that later. So for many reasons, we decided to go completely Markdown. So what you see here is the new format. It's 100% Markdown. If you use Markdown on GitHub or as I said, Stack Overflow, this will render somewhat nicely. You can use a Markdown editor to get some basic highlighting of this stuff. But the important thing here between this and the other one is it quite changed. The language did change drastically. Here it's a Markdown, and there are some semantic assumptions over the Markdown. Like this means something probably special than just regular heading in Markdown. So there was a quite big change in what the language is. As I said. Yeah. All right. So how did we deal it with the parser? Actually, I was, parser and Czechladach, it's quite probably not the same thing, right? Like I was trying to translate the word parser, and that's probably not this word, but sorry. Okay, so this is something I really couldn't wait to show you. Like this is the language I choose for writing the parser. I know what you're saying. This is the best language ever, right? Okay, reasons for why we choose C++ 11 over whatever else. I actually realized this yesterday when I was preparing for this presentation, that we are in a somewhat ironic situation in 2014, where last 20 years or something we were like, oh, I want to be platform independent, generate independent code, interpreted codes, and scripting languages. Wow, that's the way to go. I don't want to, build it on a machine. And now I'm in a situation when I came up with a language. I want everybody in the world using it, right? Obviously, regardless of where he or she is. And I'm in a situation where I don't know what the person in question is using. Are you guys Ruby, or are you guys Python, or are you guys, I don't know what, Go or .NET, or and what do I choose? Should I write the parser in Ruby or in Python? And probably not, right? It's just like, on one hand I want to be platform independent. On the other hand, I want to be like language agnostic in a way, right? Because I cannot give like Ruby code to I don't know, Python guy, maybe yes, but you know what I mean. So there is like platform independence and language agnostic, and so this is a natural choice. Going to C or C++ is it helps you to, like, you know, be more friendly towards, you know, bindings to other languages where you can provide the binding for Python, Ruby, and JavaScript, and you know, it would be much more worse when you wrote it in Python and then you want to give it to the Java guys or .NET guys or something like that, right? So that was one thing, one main reason. The other reason was that for parsing Markdown, we couldn't, well, we technically could go with the peg grammar and with peg.js, but as David said, it was not, you know, the right thing to do, and it would be probably, you know, like scratching with your left hand on the right arrow or whatever.
I was honest consultant.
Yes.
I said peg.js not
Yeah, even
suitable for
yeah,
that.
he's a really nice guy, so believe him. So David said that peg is probably not the best thing to do. Furthermore, we want to be, you know, since the Markdown is not like really, it doesn't have really like strict specification. Alright, there was the John Gruber, author of Markdown, who made it back in the 90s, and he wrote some specific sort of specification for it, but there are like many implementations. So what is de facto standard nowadays in Markdown? What is Markdown today? It's what we are used for, and usually it's the Markdown as we know it from GitHub, so it's kind of, you probably know GitHub flavored Markdown, which is, there are some little extensions, or maybe Stack Overflows and this kind of thing. So the other reason for going C, C++ was that the library that is used on a GitHub or in a Stack Overflow is written in C. So that was the other reason. One thing, C++ 11 is, you know, really cool language. It's like super awesome, and it's like I cannot stress it how cool it is. And forget about the arithmetic, you know, the pointer arithmetics or stuff like that. You don't really. There is not a single new or delete in the parser. You don't need it. This is like all thinking. If you write C code, then you will do C errors and you will see some bad access and stuff like that. If you don't do that, you might, you know, really be surprised what you can do with this crazy cool language. Except no. This is the most cutting edge language I ever seen and ever used. Because when I wrote the browser, which is like 6-7 months ago maybe, I wrote it in C++ 11 and I was like, oh, this is so much better than the old C++. It's like completely new language. They did like really awesome job, and I was shocked. And until I run it on the Ubuntu, I know there's some long running distribution, and I realized that there was no support at the time in the GCC there was like very limited support at the time in GCC on that long running distribution, and the situation is still a little bit there on the Linux. So, you know, the Apple is using the CLang or LLVM, which was pretty much the first to implement the C++ 11. The Windows did pretty good, the Visual Studio did pretty good job getting the C++ 11 there. Surprisingly, to my surprise, I was really shocked. It was the Linux when I had to like, we need to go back to, you know, C++ 98, which is like the current language. So hopefully the solution is getting better, and yeah, it's the cutting edge. You know, if you think Node.js and stuff like that is cutting edge, this is cutting edge. So yeah. Sorry, selling on that. There is also a little bit of Python in the parser, which is a project called GYP, Generate Your Own Project. It's meant to be a substitution for makefiles. It generates the makefiles and everything, and you have a Python and you have a JSON, and actually, you know, it's worth learning makefiles instead of going for it. This is utter crap, don't use it if you don't have to. Alright, okay, architecture of the parser. So, this, as I said before, we are relying on the library that's actually doing the hard lifting stuff, reading the string buffers. So I don't have to really deal with parsing the string buffers, the actual blueprint or Markdown file here. This is the library that GitHub used to, C library that GitHub used to render the markdowns. So I didn't have to write that, which is like a really, you know, a lifesaver actually, because that, and also it makes it like, it makes it very same to what GitHub is using. The problem there was no part that renders an AST. We didn't really go into these terms tonight about the parsing and grammars. I'm surprised nobody mentioned Chomsky or grammars and stuff. But we should at least mention abstract syntax tree, which is a tree that represents your source, or later maybe something a little bit else. I'll discuss it later. So you get a textual, which is plain text markdown file. It goes through the markdown parser, which is composed of a sundown and something else at top of that, which renders the actual tree, the markdown xt. And then I process the markdown xt with what I call blueprint parser, that just traverses the tree and look at what is there and applies the semantic assumptions on top of it and builds an ast of the blueprint file. So, and this is still all in Snow Crash, and you can immediately build on the AST here. If you are using a C++ library, you can serialize it into some AST serialization format. We'll be discussing this later. Or you can use a binding. This was the word I had no idea how to translate to Czech. Binding or wrapper of a C++ library to other language. At this very time, we have our own JavaScript and .NET bindings, which basically gives you a direct binary access to this part. So you don't have to write it into some JSON file and parse the JSON with JavaScript. You can immediately, you can directly call basically through the C layer all the way to the parsing. So, and the orange part is not part of the Snow Crash, so only the gray boxes are. Alright, so as I said, the sundown, that's the GitHub parser for Markdown. Ben uses, it was abandoned, it's pretty much deprecated. GitHub now moved to Ruby Markdown parser, which actually includes the sundown inside. And I don't know what it is. And there is some other movement that they took what remained from the sundown and built the C library. So the question, if you want to go if you want to be really like the real Markdown nowadays, you probably want to consider one of these two: red carpet or hold on. Okay. Now, as you've seen, there were a lot of AST in the parser structure. Again, this is the tree you are using to do something with what you have just parsed, right? So first AST is a Markdown AST. This is like a tree, or in the case of this parser, it's just a stack basically, blocks that represents the Markdown file being parsed, or the Markdown file that was parsed. Then you do some analysis on top of that tree. And you will build another tree, which is the blueprint. As you see, there is a name, there is a resource, there is a resource description, and just and there is the last part that is somewhat important, is the serialization of this tree into JSON or YAML. If you happen, this is quite important later when you want somebody actually use it, and if they don't speak C, C++, or want to go binding, they still might read JSON or YAML, right? So you want to dump it down to the file, and somebody can, get the file. Again, it's important to see what is behind it. There is this API blueprint, which is a description of your API. What somebody might want to do with it is just to parse this description file and build a website from it, like the documentation, for example. So they can either use a binding, or access this tree here and build it from there, or they can try to parse it into JSON or YAML and build it from the YAML, so they know the structure, the semantics of what is written in the blueprint. All right, that was the technical stuff, and there was pretty much nothing surprising there. But what was surprising when you come up with a language in your parser is how do you manage the project and its users. And there are many challenges in that, and of course, designing the language and iterating the design. What is, I highlighted those that I kind of sort of forget or didn't pay attention in the beginning, and then it like fired back. I was like, oh, we should like really think about this in the program. So if you came up with a language, you probably should think, onboarding, how the users get, the easiest way to get into your language and to understand, get fluent in the language. So that's something I a little bit forget to consider in the beginning. And it actually, you might say, oh, this is something that is to do with documentation or with the design language. The truth is, your parser might actually really, walk towards it and help with getting like user on board. I'll get to it later. Another important question is, who are the users of the parser, and what is the output for them, what they expect from your parser. And it turns out it's not just, oh, the users are obviously stick the file in and there is some representation of the file, I can do something like that. That's not entirely true. That's one part of the users, but there is another. I will discuss it. One other important thing is to consider, what do you do when you have your own language? You said you thought that, hey, this would be really cool if I'll put a blue snowman in there, and then you realize maybe the blue snowman wasn't the best idea, and you want to take it back. You can't, because it's out there and people are using it. So what do you do? So a lot of the those questions and the concerns I had, we addressed by being open. And I don't mean open like open SSL. I mean open like open source. And okay, so this is what we did. We went fully open source. So this is like, you guys might know it because you're working on Linux distributions. But this is my very first time. Everything I do is open source, including the planning and everything. So there is nothing like hidden and nothing, behind the curtains or anything. So it's okay. You forward. So all the projects are on the on the GitHub, including the specification of the language itself, the parser, and the AST serialization format. The issues, which works as well as milestones or planning for where the language go, what will be the next feature you want to put in the language. Both the feature of the language and the parser. It's all on the GitHub, so everybody can chime in and discuss it or ask questions. When you are a user, I'll get to it later, of the language, the Stack Overflows work really, really well for because it works as a wiki, so everybody can see what it is. What didn't work out, and I tried, was the Google Groups. It's, I don't know, maybe when I was young, it was pretty cool. This before, way before it was Google Groups. Now it was like, yeah, probably. And email, Twitter, and API support, of course. Now, what was the most important thing when you do the parser? Who are the users of the parser? And it turns out, as I said, it's not just somebody who sticks in the file and expects the output. It's actually the person who writes the blueprint, the document in the language. It's just one group I completely forgot. It's like they put a file there, you get an output. It's cool. It turns out that when you write, especially if you came up with a new language, and you want people like it or use it or at least understand it and nothing else, then you must think about this more. How do you tell people, hey, this is not good construct, this is like, there is some problem with what it wrote, you probably didn't, you might say, syntax error bomb, yeah, right? That's probably nobody want to know, because if they say it, while learning a new language, they'll be like, okay, and after a second time, they will just, So the question is really about how do you handle syntax or semantics error in your language, in the parser. That's something I really cannot stress even more than this. And you can either go, as I said, oh my god, there was a problem, syntax error, and right, or you might print the whole specification, and it's probably there's something in between what you can do. And I'm saying this because you need to realize that when you are writing a parser, it's not just came up with the grammar and with some output, some tree from that. You need to think about how you can help the people who are trying to write your language, writing the language actually. And I'm not talking about what was Mr. Sponka in English, the guy from the office, war office or whatever it was like really super annoying and paperclip guy. I don't know. So I'm not talking about this super annoying guy who's like bothering you all the time, but I'm thinking of something between there was an error or this guy, right? So you need to find that in your parser if you happen to write a parser. And one important component of this, what I completely forgot in the beginning, was the source maps. You need to in your tree that represents the initial document, the input document, you need to have a source map that will bear the information where that node is coming from, right? Where is this defined in your document? So you can pinpoint back to the document and say, on this line, and it's not just a line, it's much more. So this is the example. This is like a very simple blueprint, and I have written a response here, but I forgot to write in the status code, the HTTP status code, after the keyword response. So you can say, syntactic error here, boom, and go and good luck with the documentation. Go somewhere and find it, right? Or you can say, missing status code, I'm assuming whatever 200. Okay. So this is like a little difference between when you start writing parser, you probably don't be thinking about this little details, but it really goes a long way when somebody is about to learn a language. So again, for this you need source maps. Probably the line number is not enough because this can span like multiple lines and multiple blocks, and it doesn't even have to be from the column 1 or 0 or whatever, however you take it. And so you probably want something like at the index of characters long and sequence like that. One good point, what I realized later when I was writing bindings to JavaScript, you have UTF-8 and Python characters. Just saying. I know it's obvious, but sometimes funky things happens when somebody thinks that this is the number of characters and it's actually the byte of the string. If you have a byte buffer of the strings, it's a little detail, but it took me quite a while to realize. All right, so that was sort of one part of the users when you're actually writing a language, writing a document in a language. The other thing that I didn't consider in the beginning was what the output should look like. The abstract syntax tree, and that's something you probably came up with a language and you hope someone will start using it. And it depends where you are. If you are in a company, look in the basement, there you are doing one particular thing, and there's a parser and there is the AST, and you use it just for one purpose, then you probably can do an AST that's specific to that one purpose. Like you do some, sort of, because you know what will be after who will be using the AST. You can do something funky with the AST, making life easier for the users of the AST. But that's probably not a good idea when you expect people to use your AST for things you can even think up in beforehand, right? So somebody might use Blueprint to generate the documentation, but somebody wants to use it for testing, and somebody wants to generate the mock server, and somebody wants to control Racket with it. And if you do some assumptions around what that person want to do, then you probably might lock some other guys. So that's a very important thing when you are building the AST that comes up from your parser. I'm trying to stay most generic as I can. So really, the AST really represents what is in this input file. It's like really, there is nothing like, I don't do any operation around on those nodes. If there is a node that say, hey, this is description, I'm not doing something really, you know, let's say the description is in Markdown, right? And I have a node that says this is a description as was written in the source file, and I can generate HTML from it, right? Good. Or I can, I don't know, render it to the PNG, I don't know. I'm not doing it. It's like really, you know, really what is, it's just like plain mirror to what is written in the source document, with the difference that the machine can understand it. So you can do some optimization there and make it specific to a tool that's up in the pipeline. But if you want really, you know, go open source and you don't want to limit the users. So. And another important concern in this, when you came up with the tree, it's actually a second language because it's the contract between you and the users of the tree. And if you, you know, you cannot change the tree that, you know, as you want later. So, all right. So this is where we are at the moment. We have the very generic blueprint abstract syntax tree, but it turns out that there are some tedious work over the tree that needs to be done by most of the users. So I'm about to work on a sort of parser harness that will, you know, merge many trees from multiple blueprints and do some, you know, operations that will probably make life easier for most of the users of the blueprint or of the blueprint parser. But again, it's important that if you want, you can get the really clear imprint, you know, tree that represents the document that was under input. Okay, what didn't work out? I pretty much mentioned it. I forgot about the users who are writing the, you know, web at the time when they are writing the document. So don't do the same mistake. I had to re-implement back the source map in the original parser and even in the beta parser because there were of course no source maps. So, you know, I built the parser and it parses this tree and I was like, wow, that's cool. And then somebody took, you know, try it and it's like, what did I do wrong? It says syntax error. And I was like, so really, don't forget about, you know, giving some meaningful output when, to the people who are actually writing. And I made a poor decision when I was designing the tree that is that represents the Markdown. So I'm actually in the process of revisiting that tree, and I need to use the tree instead of the stack. And as always, I didn't quite, you know, stand up to my expectation as documentation goes of the language itself. But again, you can have like super rich documentation, and when the parser doesn't say anything, it's, you know, quite clunky. So you want parser help a little bit with the documenting part in a way that it says some meaningful things to you. And I still didn't find a good C++ programs. Thank you. So, do you have questions?
Can I somehow transfer old formats to new formats?
Yes.
Because that was my question on Twitter and somehow I didn't get any reply.
Oh, I'm sorry about
that. It was
that.
like half a year ago when you...
Well, half a year ago it probably was not possible, but now you can. There is a
website or it's on tool?
Where is it? Good question. That's the documenting part. It's definitely up somewhere. It's definitely in the repositories of API. So if you go to API, you can find it. It's written in both JavaScript and Ruby, and it gets you the Markdown for the original format. So, and then there is a gist for that. I probably quote it on
I couldn't find it.
Yeah. Okay. I'll get to it later. But yeah, it is possible to convert between those two. That's quite important.
Okay, so when you open source the parser and deploy the blueprint, were there any surprises in terms of what the users wanted which you didn't anticipate at all?
In the parser or in the language? Because in the language a lot. and that's some other, you know, that's quite different part than the parser. The language itself has some, you know, ideals about what the API design should be. And when you have some ideals, then there is always some, So with the language, yes. With the parser, probably not so much.
What about the output of the API, let's say, the AST, the format? Is it somehow stable now, or?
Oh, that's a good question. The AST of okay. So this AST, this is actually in a bunch of C++ classes. That didn't change for pretty much ever since. And the serialized AST and the AST that came up from the JavaScript binding of the parser is now stable. It's now versioned. It's now specified in its own repository. So it's actually not writing one language. It's writing like many languages. One is the API blueprint, and then on the other hand, so that's like one interface. Let's say the human side, and then there is the machine part, machine interface, and you want to stabilize and clearly say what it is as well, because people are building on top of these things, right? And that's pretty much as they are building on top of these things, the authors of tools that are using it are building on this point. So we want to stabilize the AST as well. And so there is actually, I took it to that point that there is a very separate repository on the GitHub with releases and versioning and everything and issues that describes the serialized format, which implies to the JavaScript binding. So yes.
In your experience, what is the level of knowledge of C++ 11 among C++ programmers? Do they know it, or do they just stick with C++ 98?
For some reason, I think you know the answer. Most C++ programmers are C with classes programmers, and
For a reason.
well, I don't want to, I don't know points about this on the meetups like Pyvo, but there is a day and night between C with classes and C++ 11, and I was thinking about this, and it goes back to our education and what we learn at schools, and because sure, pointer arithmetic is pretty cool, and dynamic allocations and all that stuff, but you actually don't need it if you don't really have to or you don't want to. And there is even if you are not C++ programmer, I really strongly suggest you to take a look at the 1-hour talk of Parser, who is author of C++, when he's talking about C++ 11. And sure, he talks about C++, but he talks really about the programming languages as well. And this is like really, if you look at this after his presentation, it's day and night. And there is a lot of bad attitude towards C++ because people consider it like dangerous and harmful and whatever. And but I really add it to the way they learned about C++ and the way they experience it. It's not the language. It's just how it was perceived.
It's very different, but we'll talk about it.
Okay. Any other question? Okay. Tak. Díky.